Good morning, Mr. Herman here with the second video on our trigonometry notes in Unit 2. Here we're going to have our introduction to trigonometry. So in our first video, we saw the Pythagorean theorem. We did a bit of labeling based on a reference angle, but we didn't really see this idea of trigonometry come up yet. Okay, so today is going to be the first day that we look at trigonometry. So we're going to talk about setting up trigonometry ratios or trigonometric ratios, or we're just going to abbreviate that with trig ratios. Okay, so let's review from last video that when we have our reference angle here, theta, we want to label our opposite, adjacent, and hypotenuse sides. So this side right here will be our opposite side. Now I'm going to abbreviate this OPP. Then we're going to have our adjacent side, which we said is next to our reference angle and our right angle. And I'm going to abbreviate that ADJ. And then our other side, we have across from our right angle, that longest side is our hypotenuse. I'm going to abbreviate it HYP. Now, what we can do with all of these sides is, since we know that right triangles can be similar if they have congruent angles, is that we have these ratios that we call sine, cosine, and tangent. Okay, so these are just words that we're going to need to make sure that we know and see what these equations are going to be equivalent to. So if I am coming up with the sine ratio is going to be my opposite side length over my hypotenuse side length. My cosine is going to be my adjacent side over my hypotenuse, and my tangent side is going to be my opposite side over my adjacent side. Now, you might be saying, Mr. Herman, that's a lot to memorize and to remember what those ratios are going to be, that's the pattern. Well, that's fine, because we have a little handy-dandy mnemonic device. So, with sine, we can remember that as SOH. S-O-H. Sine is opposite over hypotenuse. So, for cosine, we have ca. Cosine is adjacent over hypotenuse. And then for tangent, we have TOA. Tangent is opposite over adjacent. So we can remember the acronym SOHCAHTOA in order for us to remember what our sine, cosine, and tangent ratios are. Okay? So if that helps, go ahead and use that to memorize your sine, cosine, and tangent ratios. If you have a different way, that's fine for you to use as well. Now, these are called our trig ratios, and they are the same for all right triangles. Now, it has to only be right triangles, because I can't have a hypotenuse in a triangle that's not a right triangle, because my hypotenuse is always across from the right angle. So, now we're going to set up some trig ratios here. So, if I say sine of m is my reference angle, okay? So I'm not going to write my side labels here, because I'm using angle M as well as angle T in the right-hand column. So with sine of M, I want my opposite side, which is 8, over my hypotenuse side, which is going to be 17. For cosine of M, I want my adjacent side, which is next to my reference angle, over my hypotenuse side, which is 17. And then for the tangent, I want to take my opposite side, across from M is 8, over my adjacent side, which is 15. Okay? So 8 over 17 is my sine, 15 over 17 is my cosine, 8 over 15 is my tangent. So let's go and look at our when angle t is our reference angle. So for sine of t, I'm going to do the opposite of angle t. So in this case, it's 15. Okay, so 15 over my hypotenuse, which is 17. For cosine of t, I want my adjacent side. So that one's next to t in the right angle, over my hypotenuse. And then for my tangent, I want my opposite side, which is 15 in this case, over my adjacent side, which for angle t is 8. Okay, so hopefully we're starting to see some patterns here. Now, let's go ahead and work through the next set of sine and sines, cosines, and tangents. I'm not going to use my colors this time, though. So, with sine t, let me move up my page. For sine t, I want opposite, which is 20, over hypotenuse, which is 25. For sine of b, here's b down here, opposite is 15. Hypotenuse is 25. Let's go down to the cosine. So cosine of t is my adjacent side, which is 15. Hypotenuse is still 25. Cosine of b, there's b, my adjacent side is 20. My hypotenuse is 25. Tangent t, so here's angle t, our opposite is 20, our adjacent is 15, so that's 20 over 15. And then for tangent of b, here's angle b, 15 is my opposite, 20 is my adjacent, so 15 over 20. Now, hopefully we're starting to see a pattern between our two sets of trig ratios. So if we have sine, cosine, tangent of t, sine, cosine, tangent of b. So what we can say is that if t plus b equals 90 degrees, sine of t equals cosine of b, and cosine of t equals sine of b. So that's what we see in this pattern right here. So we're going to do a little bit of generalization. So if we have complementary angles, so that means a plus b equals 90 degrees. Sine of a equals cosine of b. Cosine of a equals sine of b. So that's a pretty interesting trend, an interesting pattern that we see. And it can become very helpful when we're trying to find missing angles or missing sides. So now we're going to go ahead and apply our trig ratios and do some problems with them. So we were finding some ratios now, but now we're going to solve for some side lengths. Okay. Now we have a nice little step-by-step process here of if we know an angle and a side, so an angle and a side and a right triangle, we can solve for the missing side length. So step one, we need to look at what side lengths we're given. Opposite, adjacent, and hypotenuse. We want to label our sides. So in this problem right here, here's our reference angle. We're going across our triangle. There's our opposite side. We are next to our reference angle and the right angle. Here's our adjacent side. Okay, so we labeled the sides. Now, which trig ratio uses the sides that we know or want to find? So we want to find opposite and we know adjacent. So if I think of opposite over adjacent, I want to be thinking of tangent. Okay, so we identify the ratio. So now I want to set up the appropriate trig ratio. So I'm going to start with tangent, and then my angle is going to go with my trig function, in this case tangent. So tangent 23 degrees equals, and then I set up a fraction here. My opposite side we said was x, and my adjacent side is 14. So I want to get x by itself, times by 14 on both sides. X equals 14 times tangent 23, and then I just go straight into the calculator. Now, if we're trying to find this on the calculator, tangent is going to be right here in our calculator. So just above the numbers, a couple rows, we'll see tangent, we'll see cosine, we see sine. Okay, so I'm going to type in 14 tangent 23, close my parentheses, hit enter, and then I'm just going to round to the nearest tenth, so one place after the decimal. Okay, so let's go ahead and solve another one. On this problem right here, we identified there's our reference angle. Let's label our side. So we have 12, which is opposite, and we have x, which is the hypotenuse. So if I'm thinking of opposite and hypotenuse, I want to think of sine. So we're going to go set up my trig function of sin, sine 21 degrees, that's our reference angle, equals my opposite side of 12 over my adjacent side of x. Now, what I can do here is if I'm trying to get x by itself and I have a fraction, it's in the denominator, I can just swap the place of the left side and my denominator. Okay, now x is by itself, so we're good to go. I'm going to put this in the calculator. Now I want to be careful here. 12 divided by sine 21 parentheses. I have to include the second parentheses or else it will not divide by what I wanted to divide by. Okay, order of operations there. So x equals 33.5. We'll just round to the nearest tenth. And then our last one here, we've got two sides and one angle. So here's our reference angle, 45 degrees. We have 10 here on the side that's next to our reference angle and our right angle. So there's our adjacent side. We're on the long side across from the right angle, so that is our hypotenuse. So if I have adjacent and hypotenuse, what function do I want to use? I want to use my cosine function. Okay, so I'm going to go set up my trig ratio. So that cosine of 45 degrees equals adjacent, in this case 10, over hypotenuse, which is my x. So I'm going to rewrite my equation here, 10 over, swap my left in my denominator, and then once again I'll put that in the calculator. So I have 10 divided by cosine 45 equals 14.1. So we've now worked through identifying trig ratios and solving to find missing sides with our trig functions. So let's go ahead and do a little bit of practice on both of those so we can keep building up our toolkit to solve our right triangles.